Hi everybody, welcome to the recap video for Stats 220 online for week 8 of the course. The previous week you watched learning modules about the process of statistical testing. So let me just briefly review what was in those learning modules. So first of all, we talked about a test for proportions, which goes something like this. So we have a null hypothesis, H0, that P, the true proportion, is equal to some value P0, versus the alternative that P is, let's say, greater than P0. There could be other possibilities. This is a one-sided alternative. It could have been P less than P0, or P is just different from P0. P is not equal to P0. But let's go with this one now. P is greater than P0. So the process involves calculating a test statistic. In this case, we'll call it Z observed. And it's obtained by taking the sample proportion, P hat, minus P0, divided by the standard error, P0 times 1 minus P0, divided by N. Now notice I've calculated the standard error assuming that P0 is the true value of P. So this assumes P is equal to P0. In other words, that means that the null hypothesis is true. So in other words, H0 is true. So now this leads us to the calculation of the p-value, which is the p-value is equal to the probability that Z is greater than Z observed. And so the picture of this would look like we have a normal distribution with mean 0 and standard deviation 1, and the value of Z observed is, let's say, over here, and we're calculating the area to the right of that. Now if that area is very small, that means that under the assumption that the true distribution is normal with mean P0, standard deviation P0 times 1 minus P0 over N, then if that area is very small, then a value of Z observed greater than or equal to that value is not very likely under the assumption of that distribution. Therefore, that means that that's evidence against the null hypothesis. Let's move on to the first question on the hand-in problem for this week. So the hand-in problem for the first problem for the hand-in problem was that a research study found that among 2,482 boys ages 7 to 12 years old, 461 were overweight or obese. On the basis of the study, can we conclude that more than 15% of the boys ages 7 to 12 in the sample population are obese or overweight? Well, here's the solution, but how did we arrive at it? Well, the null hypothesis in this case is that P is equal to 0.15. The alternative, the claim in this case, is that P is greater than 0.15. So let's do what we just did in the previous, what I previously discussed. So we'll calculate the Z statistic, the observed value, the test statistic, and that's equal to P hat minus P0 divided by P0 times 1 minus P0 over N. So what are all these values in this case? Well, P hat is equal to 461 over 2482. That's our data. And that's 0.19. P0, this is P0, is equal to 0.15. And N in this case is equal to 2,482. Let's plug in all the numbers. So it's 0.19 minus 0.15 divided by 0.15 times 1 minus 0.15 divided by 2482 square root. And if you work out that value, that's equal to 5.58. So the p-value in this case, the p-value is equal to the probability that z is greater than z observed. And the value of z observed is 5.58, probability z greater than 5.58. And that's a very large value in the normal 0, 1 distribution. It's way, way, way out here. It's almost 6 standard deviations away from the mean. That's 5.58. And the area to the right of it is essentially 0. Now let's go through the second hand-in problem. Second one is the incidence of schizophrenia in adults is about 2%. A proposed screening test is estimated to have 95% accuracy in making a positive diagnosis and 97% accuracy in declaring a person is not schizophrenic. So the hypothesis test that was tested is that a patient is normal, and the alternative is that a patient is schizophrenic. Suppose the p-value for this test is 0.03. Is the p-value of this test the same as the probability that the null hypothesis is true given a person tests positive for schizophrenia? Well, the interpretation of a p-value is not that the probability of the null hypothesis being true. So the p-value is not equal to the probability of the null hypothesis. That's point number 1. In fact, what is the p-value equal to? It's equal to the probability that we would obtain data as extreme or more extreme under the assumption that the null hypothesis is true. So it's the probability of the test statistic value as extreme or more extreme under the assumption that the null hypothesis is true, that H naught is true. And so the difference between these two really comes out in this question. So let's go through the question. So what is the p-value? The p-value is basically, it's given here, is that the probability that the test says that a patient is schizophrenic, so given that H naught is true. And that's equal to 0.03. We're also given that the probability that a patient is schizophrenic is equal to 0.02. And the probability that the test is says that they're schizophrenic when they actually are schizophrenic is equal to 0.95, and the probability that the test says that they're not schizophrenic, so test is not schizophrenic, and they're not schizophrenic, is equal to 0.97. So what we can do is we can actually put all this information into a tree diagram. So how can we do that? Well, let's start. So if patient can either be schizophrenic or not schizophrenic. And so if they're schizophrenic, the prevalence is about 0.02, and that they're not schizophrenic is 0.98. And among the people that are schizophrenic, the probability that they'll have a positive test is 0.95. And the probability that they won't have that they'll have a negative test is 0.05. Similarly, in the no schizophrenic population, the probability of a positive test and a negative test, well, we're given the negative test is 0.97, so that means the probability of a positive test is 0.03. And so we can put all this information together. So what are we looking for? We're looking for the probability of H naught, given that the test says that the person is schizophrenic, which is the same as the probability that they're not schizophrenic, given that the test is positive. And then that is equal to 0.98 times 0.03 divided by 0.98 times 0.03 plus 0.02 times 0.95. And that's equal to 0.607, which we see is quite different than the p-value of 0.03, which is not equal to 0.03. So that's it for this week for the recap video for Stats 220 Online. I hope you have a good week, and I will see you online next week.